Welcome, guys. Virtual Mr. Nichols is back for one, hopefully, final day. We're going to go through the triangle proofs day number 1. This is all about proving triangles congruent again and some of the faster ways that we can do that. And with this, a lot of these names and methods you have actually already been introduced to. They are just slightly used differently. So the big thing about this, and I'm just going to mark the diagram more than label anything, when we have two things that are congruent, you just try to match up. Again, the big theme of this is first with the first, middle with the middle, last with the last for those congruent pieces. So this is more of a review for you. Angle T should be congruent to angle A. R should be congruent to G. I congruent to L. And then any pieces that connect the same single to double, single to double, single to single, single to single, leaving the last piece. So remember, there are 6 pieces that are all congruent. But very similar to what we talked about with similar triangles, when we want to prove that triangles are congruent, we don't need all 6 pieces. We actually only need 3 pieces most of the time. And so through here are the methods that we can use the 3 different pieces. Again, the names you might recognize, slightly different use though. For example, side, side, side. In this example, you have all 3 sides are congruent. So unlike what we did with similar triangles where they needed to be a scale factor apart from each other, these are just strictly, they're identical to one another. And so as long as you have a congruent side, and a congruent side, hence side, 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 you know you've got that method up and running. Side angle side, again, similar to what we saw earlier. You'd need 2 sides, but then most importantly is you would need the angle that is included between those 2 sides. And once again, with side angle side, it's just a matter of having one congruent side and included, or actually write this, congruent included angle. And the last thing would be a congruent side again. So those 3 pieces would also work. The other ones, angle side angle. So this one's slightly new, where if I have some angles that we have next to each other, if I know these 2 are congruent, then I actually just need the side that again is included in between it. And that's what you'll notice here as well. The side is in between the angles when we look at angle side angle. You need to verify that that is the same over here. So from this you have a congruent angle, a congruent included side, and another congruent angle. Angle side, this is where I often look like is when you travel around the triangle, you should see these in this order. So it's 2 angles congruent and then the side that's not in between them. So you have 2 options of that. So I'm actually going to draw this picture exactly like what we drew right above to show you the difference between this. So last time we had used these 2 sides, which were in between. For now, what we need is we need 2 of those sides to be not in between, is what we're really looking for there. And with that, we're again looking for a congruent angle, a congruent angle, and then we can say that this is just any other congruent side as well. And last but not least, hypotenuse leg. This one deals strictly with right angles. So technically, that is one thing that we would know that these 2 triangles have congruent already. I know we're technically missing a 3rd letter, but the first one's technically that they're right angles. So we do have that they both have 90 degrees. From there, what we're looking for is you have to make sure that you have the hypotenuse of one of these triangles and the hypotenuse of the other triangle congruent. Remember, your hypotenuse is the side that is across from the right angles. And then after that, as long as you have the right angle, the hypotenuse congruent, which I have to mark really quick, you also just need one other leg or one other side congruent. So this one, the big 3 pieces, you have to have yourself a right angle, You have to have yourself a congruent hypotenuse and a congruent leg. So those are the 5 main ones that you guys will see. We will be seeing them pretty much the whole entire unit from here on out, so the sooner you can put those in the memory bank, the better. The reflexive property is something that we'll talk about also, and I'm going to try and highlight these in similar colors for you. But what that is when a segment or an angle is really shared by the 2 different shapes. And so it's like when we use one side for both of the shapes that we're looking for, this would be something that we use what's called the reflexive property. I can already tell you where these are going to pop up, and these might be things you want to color coordinate for yourself. These blue lines that I'm highlighting, I think there's one down at the very, very bottom I wanted to get also. But these blue lines are the reflexive properties, the sides that are being shared between the 2 shapes. So what we're going to do now is we're going to utilize those 5 methods. Notice the hypotenuse leg is also going to be one that we include in here. But otherwise, we're going to tell you if they are not congruent as well, if for some reason none of those fit for us. So let's take a look at this one. Here, I'll note I have one side, 2 sets of sides, and technically, because I do know that this is the reflexive, I do have that 3rd side as well. So technically, these are side, side, side congruent. Over on this end, it looks like I see the right angle, so I first went for hypotenuse leg, but I actually recognized pretty soon that we didn't know that these hypotenuses were congruent to each other. So instead of using that method, I came through and said, well, do we have an angle, an angle? We've got a side, I'm sorry guys, messed that one backwards. We have a side and a side. We have another side and another side, and the angle that's in between them, ladies and gentlemen, this one would just be angle, side, angle. Side, angle, side. My bad, ladies and gentlemen. Side, angle, side is the one that we have there. Number 3, we've got another reflexive property. So whenever I see those, I try to mark them right away. Hopefully they can indicate to you guys that looking at these, I've got an angle, side, angle relationship here for both of those triangles. And again, I look at these as like, if I was to name these, as I kind of travel around the triangle this way, I run into the angle first, then the side, then the angle. It's just kind of the order that you travel around that triangle. Number 4, I look at this one, we have angle, angle, angle. This one used to work for similarity. So if similar triangles, if you had 2 angles that were congruent, you knew the triangles were similar. Unfortunately, for congruence, that's not the case. The angles could all be the same, but the triangles could technically be different sizes. So these ones are not covered. Thus, these are not going to be congruent. Angle, angle is not allowed for congruence. Over on this one, though, if I take a look, I do have an angle, a side, an angle. Those repeat in both of the triangles, so we have an ASA relationship. And last but not least, I have a side, an angle, and a side. It looks like the angle is squeezed in between the 2 sides as well. Wait a second, I lied. It's been a long day today, guys. This one looks like angle, angle, side now that I look at it right here. So looking at that relationship between both of them, that's usually the hardest one to find and recognize. And it's again just identifying that you have the 2 angles and then the one side that is not in between those 2 angles. All right, last pieces for the notes portion that we have here. What I like to do with these is, so they're giving us 2 triangles and they're saying what piece are you missing in order to find that these are congruent. I am a big fan of, again, drawing these triangles separately. Sometimes you can highlight them and see them where they are. So for example, if I have PWT, I have this one right here. I'm just going to color it in for us so we can see it really nice. And then I also have SVR. So these are 2 separate triangles that we might be able to look at. But if they ever overlap each other, that's when I usually draw them separately so I can really get a good look at them. All right, so if I wanted these to be angle, side, angle, I notice I have terrible color schemes. I have an angle, a side. It looks like the angle that I would need to be congruent would be this angle right here. and this one right here. And I know I put a right angle symbol. I'm not sure if they're right angles. But those are the two that should be congruent. So I need angle P to be congruent to angle S. For side angle side, you kind of travel around again. You have your side, you travel then to your angle. The side that you're missing after that would be TW for the yellow triangle. If I did this for the other one, for the blue triangle, I'd have a side, travel to the angle, travel to the side. So I'd need this one to be VR for me. Oh no, guys. I drew into them. I can't get this one done. Oh, yeah, it's gonna have to be re-highlighted. And last but not least, for angle side angle, or I'm sorry, angle side, it does look like these are the two angles that we would need. So you'd have two congruent angles and one side that's not included in between them. So I would need, and we can't name those V, yeah, we technically can, with the triangles that we see. We can say angle W from the yellow triangle and angle V from the blue triangle. For the right side, this one's the one I'd say is a little trickier, because if you look at the triangles we are trying to use, AEC is this one right here. BEC is the blue, or I'm sorry, DEB is the blue one that we see here. So they overlap a little bit. It might be a little bit easier to draw them separately. Conveniently for us, I can just take my blue one, move it here, take my pink one, move it here. I'm just going to label these accordingly. The pink one was A, E, and C. The second one was D, B, and E at the bottom. And so with this, we had some markings on it. We had AE had this marking, DE had this marking. We had CE has a circle on it, and BE has a circle on it. And now we're able to really take a look at this. So if I have these two triangles by side, 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 I would clearly just need that third side to be congruent on both of them. So that'd be BD and AC. And then for side angle side, we have the two sides already. We would just need the angle that is included in between them. And in this case, I would need angle E. Notice though, we'd have to like name it. There's a lot of angles at E. So technically, I would probably name it something like angle bed. Has to be congruent to angle AEC. So those are usually the fun ones. There is this last one. I'll spare you kind of a little bit of what this one is. You would just take all these numbers, so this plus this plus this plus this, you'd set it equal to 85 so you could find out what x was. The whole point of doing that was just to figure out, could you prove that these triangles were congruent? When you plugged in your x value, you would have gotten a 22 here, a 22 here, a 20.5, a 20.5. And basically what we were trying to show you guys is that we had one set of sides congruent here, a second set of sides congruent here, and then the blue line, remember that was the reflexive property where we use this blue line for both of the triangles. So this one was one that, yes, you could use technically side, side, side to prove these congruent. It was just a long, drawn-out problem. I don't want to waste your guys' time with that one. But again, how you approach that problem should be well known. To repeat it, find the perimeter, add them all together, set it equal to 85, solve for x, plug it in, and then from there we got side, side, side. But the big one that we have for takeaways is going to be the proofs. Now, these are usually everyone's favorites, but it's probably going to have to do something with the reflexive property for right now and just proving triangles congruent using one of those 5 manners that we have. Remember, your given statements are always the first things to go here. The first reasoning should be given. Those are some freebie points. Also, another reminder that your prove statement should always end up being the very last statement that you put down here. More freebie points for you guys on those as well. Everything in the middle, you do have to figure out yourself somehow. So let's check this out. First thing it says RU bisects QS. So remember, bisecting means that we go ahead and have two congruent sections. It tells us QR is congruent to QS or to SR. And they want to figure out is this triangle on the left-hand side, is this triangle congruent to the triangle that we see on the right-hand side? And from the looks of this, just from the markings that I've indicated, it looks like we really do know this third side is going to be congruent as well because of that reflexive property. And so because of that, all those red markings, I can see I have side, side, side. I just now need to prove that. And so sometimes it's really nice where you have the drawing finished. We can come down here and say, I know that triangle RUQ will be congruent to triangle RUS, just rewriting that proof statement. And we can clearly see that it's going to be because of side, side, side. So now we have to prove logically why this happens with statements and reasonings. So the first thing I noticed is that the reasoning had something to do with the word bisected in it. So I come up and I'm like, oh yeah, remember how I wrote these two things down? I wrote that QU was congruent to US because it got bisected. That's the first thing they're asking us to do as well. Can you remind yourself that when you put markings on the diagram, you very often need some sort of statement and reasoning because of that. So those are the first markings I put on. The second markings I put on were actually the given statements that we had here, so I'm not going to deal anymore with that. But the third set of markings I put on was this one. Oh yeah, guys, guess what? That is the reflexive property that we have here. So quite literally, all I need you guys to do is write the word reflexive. I did forget the reasoning to the one above it. If a segment is bisected, then it is split, divided, cut, however you want to say it. And the big other one is into two congruent parts. I do need to have that in there somewhere as well. So that wasn't too bad. From there, we were able to prove those two triangles were congruent because they had all three sides congruent. Because they're all three sides were congruent, that satisfied the side, side, side congruency. We now have triangles. That similar approach will happen with these other ones as well. Let's go ahead and highlight the triangles that they're looking at here. So if I look at this proof statement, they tell me triangle GEO. So I'm going to take my highlighter. I've got GEO seems to be right here. And then last but not least, I also have OMG, which is just this other blue triangle that we see right here. All right, those are the two triangles I'm looking at. If I have my information now, it does show that I have a bunch of parallel lines now, guys. Huge things. They're telling me GE is parallel. They're telling me GM and OE are parallel. Whenever you guys see parallel lines, I want you thinking transversals, because what ends up happening here, and oftentimes when you see these triangles, that split line right there, we want that to be the line we use for the transversal. And for, let's see, a good color for these guys, maybe green. If I use now this line and this line as the parallel lines, you might recognize something, because angle 4 and angle 3, this one right here and this one right here, are alternate interior angles. So we can use that to help us out now. That same exact logic. So first off, I'm going to add this down here at the bottom. If I looked at the numbers I circled number 3 and number 4. Number 3 is down here, so they're saying, hey, that has to match with angle number 4 because I know that those are alternate interior angles. They're also asking for angle number 1, though. Well, if I look at angle number 1, it's actually just about leaving that transversal that divides those two triangles, but just using the other set of parallel lines now. Because if I use these, I can now recognize that angle number 1 and angle number 2 are the congruent sides there. So again, just use that transversal that divides those two triangles and just switch up what lines you're using as the parallel lines. Tends to be a pretty good way of getting that done. But angle 1 should have been congruent to angle 2. All of that was due that if lines are parallel, then those alternate interior angles are congruent. So if you looked at that, the markings that we had here, I have angle 4 congruent to angle 2. I'm going to do this in red really quick so we can see it. Angle 4 is congruent to angle 2. Sorry, angle 4 is congruent to angle 3. Angle 1 is congruent to angle 2. So from these together, what I'm really looking at here is I'm saying, wow, let's look at this blue one. I have two angles. I wish I had the side that was in between it. Here on the yellow triangle, I've got two angles. I wish I had the side that's in between it. Well, guess what, guys? That's the same side for both of those triangles. That's that property we learned up top called the reflexive property. So we just list that same exact side twice. We say, hey, GO is used for one triangle. GO is used for the other triangle. Those two are congruent because of the reflexive property. The final statement, you should be able to take your proof statement. Triangle GEO is congruent to triangle OMG. The reason that we knew that, it looks like I had an angle side and an angle. I have an angle side and an angle in the other triangle as well. That's the relationship that we're going to use to prove congruence. There is one final one to go through. If we look at the triangles TUR, I'm going to just highlight them so we can see which ones we're talking about. KYR, or KRY, however you want to name it. All right, those are the two triangles. First thing they tell me, R is the midpoint of TK. So it's saying TK is the line that's getting cut in half. So that means this little piece could be congruent to this little piece. Okay, I like that. The second thing that they tell me, point R is the midpoint of UV, or sorry, VY. So now this line is the one that's also getting cut in half. You are congruent. You are congruent. And then from here, we kind of look at, I kind of look at the diagram. I say, okay, I've got two angles. If I have two angles, I have two sides. With two sides, I can either have the third side congruent, which they didn't really tell me information about this last side here. But they did tell me some information about the angle that is included between them. Angle number 3 and angle number 4, they are vertical angles. Because of that, I can see I have a side angle side relationship here. I have a side angle side relationship right here as well. So let's see where they got us for our statements. Which two angles were the vertical angles? It looks like I could name that angle number 3 is congruent to angle number 4 because of their vertical angles. From there, they also stated something that, hey, if you're the midpoint, then it's going to split, and this is that second half, into two congruent parts. So from the given statements that we had up here, what actual two segments were created? Well, the first ones we drew were TR and RK. If you look at this, they have TR, so let's put RK next to it. The other one that they mentioned for us, we had UR and RY. They have UR right here, so we just need RY. After all of that, I know that these two triangles are going to be the final statement that we have for the prove, or for the statement. Triangle TUR is congruent to triangle KYR. And the reasoning, as we mentioned earlier, was I have one side, one angle, an included angle, and one other side congruent for both of these triangles. Little long set of notes for you guys, but you guys have worksheet number 6 for homework. All the keys should be posted for you guys if you wanted to look at those as well to get some resources for some of those problems that are a little tough. Make sure to bring some questions tomorrow. I will hopefully be back tomorrow as well for you guys. We'll see you later.